Hello, I'm Chris Vavra, and I'm the Web Content Manager for CFE Media and Technology. I'm here today to discuss PID control loop tuning with Brian Fenn, COO for Avanceon, a CFE Media and Technology content partner. He is a specialist in automation and manufacturing IT for SCADA and MES systems. He is an expert in PID control loop tuning, and he is here today to describe a project that used PID control loops to find inefficiencies and losses and make for a better process facility. He will also show some examples of how this looks in practice and how others can use these techniques in their process facilities. Welcome, Brian.
I really appreciate being here, Chris. Thanks so much for having me.
Well, glad you are here as well. So I guess to start, could you give us a brief description of the project you're going to highlight here today and how PID was involved in this?
Absolutely. One of the largest sources of inefficiencies and loss in many process facilities is in the operation and accuracy of the PID control loops. These loops, often poorly tuned and not set up with the right process parameters, control both energy use in terms of hot water, steam, and refrigeration, as well as cycle time, how long it takes to heat or cool things. And most manufacturers accept these losses as normal or the cost of doing business. But Avanceon has been offering solutions to address this and other operational inefficiencies through analytics and machine learning by offering quantifiable assessments of the current state and being able to provide a path forward with concrete steps to improve their operations. So the project we wanted to talk about today was with a top food and beverage manufacturer who came to us and said, hey, we don't really know why, but it really feels like our CIPs are taking too long, and as a result, we're losing out on production time. And so can you help us out and take a look and help us figure out what's going on? And so we performed our PID analytics service to dig into the historical process data. We identified their largest efficiency offenders and then captured the recommendations for how to eliminate those problems. From that recommendation, a remediation plan was developed.
So could you go into a little more detail about the project scopes and some of the more specific goals your client had for you, as well as goals you developed?
Sure. Let me share my screen here.
Okay.
And so when we work with customers on their analytical journey, we often start by discussing the different types of analytics. And so I really like using this graphic because it really helps to illustrate how the changes in complexity of the type of question that you're asking can help impact the value that that answer can provide. So kind of moving from the what to the why to the what might, and then the if then. And a common progression we find with customers is to start with simpler, lower cost descriptive analytics to start showing value, and then expanding that into more complex analytics as they start to see that return. So in this case, we looked at 10 CIP circuits that each had two loops, one for temperature and one for flow. And we reviewed over 2 years of data in order to help identify patterns and trends and to develop some insight into the reason for those losses, along with some potential resolutions to address them. So for this particular project, we pulled together a report card of their current performance and then provided a detailed recommendation and action plan to help close those gaps. And so currently we have a subsequent project going on that's addressing these different root concerns.
Yeah, and this is not unlike, I suppose, what you would see in other projects, trying to, find, problems before they happen, using like predictive and preventive and prescriptive maintenance. But this is, I guess, more from an analytics and number crunching side rather than perhaps, machine failure or something along those lines, like you might see in a mechanical plant.
Yeah, I mean, here they did have the data and information for what was going on. They did have the charts and graphs for the PID run, but they were really struggling with that why question. Why was it that these things were taking so long? And so that's where we really focused on this diagnostic analysis to help get at those different underlying issues.
Right. And in this project, what types of automation, controls, or instrumentation hardware, software, and networking systems, what was involved here in this project?
Sure. So when talk about a typical analytics flow in manufacturing, we start at each of the different locations where they have one or several data sources where information is being stored. And so given a certain problem or certain area of investigation, that data is analyzed using one or more of a variety of tools. We often use R, Azure Machine Learning, Alteryx, and Python. From there, that analysis is used to form the basis of some kind of remediation or continuous improvement effort that's then shared with the appropriate parties to develop a plan and take action, often via Power BI or Tableau or something like that. That then results in changes to the facility, with new data being generated to be analyzed for the effectiveness of those changes. And then in some cases, we're able to take the results of our analysis and feed them directly back into the controls or display to the operator so that they can take some more immediate action and real-time response. In this particular case, we leveraged Alteryx and Power BI. So I did want to share our analytics workflow here in Alteryx. It's definitely a little bit of an eye chart, but I just wanted to kind of walk through the different stages and phases of the analysis. And so it starts with the data connection, connecting to the different data sources that we're going to be using for our analysis. In this case, the customer was using PyHistorian. From there, we go into our data prep, so identifying and relabeling the data that we're pulling in. Then we have a really big and important step, which is where we test, clean, and filter all of our data. And that really provides the contextualization for the data and allows us to tag specific instances that are going to be important for our analysis later on. And this is really, the unsung hero of data analytics. It's kind of the gatekeeper to avoiding that old expression of garbage in, garbage out.
Yeah.
Our next step then is the analytics, right? And this is the sexy part, all the algorithms that perform various tests. In our case, we're going to score how well loops performed in some variety of ways.
Yeah.
And then finally, we have the output. So taking those different results and making them available, in this case, to a Power BI report card.
Yeah. This might be skipping ahead a little bit, but it seems like machine learning and being able to process and learn from all the data that's being gathered. It seems like that's been a major development for PID in the last several years, being able to more intelligently gather and articulate the data that's being gathered in the system.
Yeah, absolutely. And I think, like I was touching on, one of the biggest things is that contextualization and really understanding exactly what's going on with the operation and how that's impacting the data. Being able to really understand what are the important parts to measure. Really, again, it's really just avoiding that garbage in, garbage out. If you don't do all those right steps, your actual analysis is going to be off.
Right. So for this particular project, it seems like you had a pretty good idea of what was needed and what needed to be done. But what were some of the challenges that came up in the project that you had to work with, not only from the PID side, but as things came up?
Yeah, so it's really understanding what we're seeing with that data. So, we start out with a whole bunch of raw data that we're getting from the historian. And so we're trying to turn this into this. And you know what? That might not seem like a lot. It's still a bunch of columns of data and that kind of thing. But being able to shape it in that meaningful way that's useful for further analysis is what's really important. And so we're able to do that through a couple of different ways. One, on our side, we're able to do things like event identification. So really making sure that we're targeting specific instances and moments in time based on what's happening inside the process. And then also data scrubbing. So making sure that any, operational or physical mishaps, you hit an e-stop or a transmitter fell off or whatever, you don't want that kind of thing to skew the data and skew the results. Right. So making sure that that's all cleaned up. But then also working with the customer to understand what's going on inside of operations as well. So certainly things like recipe parameters and operational schedules, but also understanding any changes in the system that might have occurred over time. So what we typically do is we'll do an initial data analysis, and then we'll get together with the customer to really fully understand that proper context, kind of walk through any of the data assumptions that we have, and just make sure that we're understanding exactly what we're seeing.
Right. And also being sure to explain why there might have been, those, as you say, outliers or some of those other little inconsistencies that you were able to smooth out along the way.
Absolutely. And then that helps lead us to, where do we need to track and look for those elsewhere? And, how can we make sure that what we are actually testing is when it's running properly, and in the time slices that we want to be measuring.
Sounds good. Are there some specific positive metrics you'd like to share about this project that really stood out to you?
Yeah, absolutely. So at the end of the day, this was the report card overview that we presented with the customer. So we have all the different loops, generally how they performed, and then some grading for each of the tests. We have some different write-ups that walk through some of the sample runs, to give an idea of how it was performing and some of the different things we find. And then we really get into some of the details of the tests. And so for these particular PID loops, we were doing 4 different tests. One was our passive engagement test. So when the loop was being called on to perform and do its duty, how often was it actually being used? The PID algorithm was actually being used versus being in some kind of manual control. Secondly, we looked at how the loop was actually performing. How well does it hold set point? And we were paying particular attention to the wash phases, right? Because we're talking about CIP, temperature and flow, being most important during our wash to make sure that everything is properly cleaned. Our third test then looked at how that progressed over time. So we took a couple different time slices and saw that, is the loop performing better or worse over time? And then finally, we take a look at how each of the different phases are doing. And so phase by phase, is it performing better or worse than some of the other phases for that particular loop? And so at the end of the day, not only did this give them specific quantifiable detail to that general feeling of poor performance, but we were able to discover significant savings in both energy and runtime due to a number of issues. We saw issues with the PID implementation. There were both general and multimodal tuning parameter changes that needed to be made, as well as taking a look at the auto to manual transfer. And so we've been remediating those loops to realize the benefits. And then in addition, many of these issues that we were able to identify on these initial 20 CIP loops actually affected more than 100 additional loops in various processes. So through our process, we were able to identify that. We've been making those changes through this initial remediation too. And then we'll be doing some further targeted analysis of those other process loops to see if there's more benefits that we can gain there as well.
So it sounds like a really good success story, because not only were you able to find like one initial problem, you were able to show that this was a problem that, was infecting the entire facility, and you're able to really kind of get it all knocked out in one fell swoop, all thanks to, using the data you had synthesized and evaluated in that first control loop project.
Yeah, absolutely.
And finally, I guess, this was obviously a very successful project for you and for your client. What were some of the lessons you learned through this project, and what advice do you think would be beneficial not only for your client, but for future clients as you perform this project for others?
Sure. Yeah, I think the biggest thing is really just not to accept that operational, it is what it is, and accepting how things are. really looking for innovation from the new tool sets that are available through the Industry 4.0 as a realistic path to shed light on those prior, unaddressable plant performance issues.
Yeah, definitely. And, information is, I think, more than ever king in manufacturing. Information, can really be the difference between a success and a failure. And I think this using machine learning and all of that and big data to really capture all of that information and make it not only beneficial but kind of user friendly. I think through those charts you described and showed, I think is a great tool that would be useful in other projects as well.
Absolutely. And that's one of the great things about manufacturing. There's a lot of data out there, right? Manufacturers have been collecting a lot of data around their process for years, and it's just sitting there waiting to be tapped in and finding some of this value.
Absolutely. Well, thank you, Brian, for sharing this project and the highlights today on PID control loop tuning. Very much appreciated you taking the time to explain and walk through this with us.
No, thanks again for having me, Chris. The pleasure's all mine.
Well, thank you. And I'm Chris Vavra, Web Content Manager for CFE Media and Technology. If you enjoyed this video today, we have many others on different tutorials and project descriptions on our Control Engineering YouTube channel. A link will be provided for you at the end of this, at the bottom of the story, if you are reading this online at controlengineering.com. So thank you all for watching and have a great day.